Hello, my name's Davina and I'm a fourth year electrical engineering student.
My name's Zuni and I'm a fourth year renewable energy engineering student.
My name's Daniel and I'm a fourth year photovoltaics engineering student.
Hi, I'm Winky and I'm a fourth year renewable energy engineering student.
Hi, my name's Anthony and I'm a fourth year photovoltaics and computer science engineer.
Hi, my name's Anmol. I study electrical engineering and we're getting ready to leave for the World Solar Challenge.
On SunSwift, I serve as an electrical engineer, systems engineer and the solar car driver.
I'm the electrical engineering team head.
On SunSwift, I'm the photovoltaics team leader.
On SunSwift, I'm part of the mechanical and systems engineering team.
On SunSwift, I am part of the photovoltaics team.
And I'm the strategist for the UNSW SunSwift team.
SunSwift is currently attempting to turn its solar car Eve into the first road-legal solar sports car in the Southern Hemisphere.
Effective leadership at SunSwift is crucial to the team's success. Our team leader pushed a vision to build an attractive, practical and reliable road-legal solar car. Part of influencing and steering the team was done with motivation segments in every weekly meeting to remind the team how much they are achieving and the enormity of what they are aspiring to do. The other parts of the weekly meetings were devoted to managerial tasks to keep track of progress, make plans to keep everyone up to date and accountable. In 2014, Hayden Smith, the project director at the time, boosted team morale by giving a TED Talk on TEDx Sydney, which had a strategic goal of promoting the team in the public eye in order to attract more support and funding for the team in future. Leadership at SunSwift has not been without problems. Our leader was faced with tough go, no-go decisions, such as whether or not to proceed with our land speed record attempt. This decision involved a cost-benefit analysis and feasibility study, weighing up dollar cost, personnel capabilities, and strategic goals such as fleet training for future team members. From a management perspective, there was the issue of keeping track of progress and deadlines while balancing workload between student volunteers. This was addressed with the adoption of a task tracking system called Jira, allowing sub-team leaders to effectively manage their assigned tasks to a timeline. With the exposure to real leadership and management situations, the SunSwift project has been an extremely valuable experience for the whole team.
One major issue present within the World Solar Challenge was how teams dealt with trade secrets, innovations, and new ideas. Due to the competitive spirit of the event, most teams, especially at the top, kept secret their strategies and innovations to keep the leading edge. Two winners of this year's challenge, New One Solar Team and Solar Team Twente from the Netherlands, were separated at the finish line by a tight 3 minutes. Both cars were near identical in design, with the exception of the positioning of the driver cockpit. With the same solar array, motors, batteries, wheels and tyres, any small advantage would mean winning the race. The winning car, Nuna, weighed in at 150 kilograms, while Twente's weighed in at 151 kilograms. Close to the finish of the race
in Adelaide, teams would listen in on competitors' radio channels for hints of set speeds and overtaking in a way of gaining a competitive lead. One may easily question whether this is a form of cheating or simply a part of strategy. Solar car shapes and design concepts also raise ethical questions. In 2013, the SunSwift car Eve was built with a large underbody wind tunnel, which reduced our drag coefficient, improved our aerodynamics, and ultimately put us first across the finish line. This year, both the top two winning teams in our class had incorporated a similar wind tunnel design into their car. Innovations get passed on year after year, and without the conditions of copyright and design patenting, nobody really owns solar car designs.
So on the SunSwift team, I am also an outreach officer. This role involves me going to numerous schools and public events to showcase and exhibit our car. One key point we use to appeal to the general public is by emphasizing we are creating a car that can be the future. A solar-powered car that does not run on nasty fossil fuels, which is contributing to climate change and global warming. It creates a sustainable, emission-free and environmentally friendly image. However, what the public does not know is that the materials that we use is not very sustainable. Carbon fiber is not only very expensive, but difficult to recycle and has a large carbon footprint. Carbon fiber, because of its nature and characteristics, is neither biodegradable nor photodegradable. I can quite confidently say that nearly all solar-powered vehicles is made of at least 60% carbon fiber. Is it really okay for us to mislead the public into thinking solar-powered vehicles are sustainable? As engineers, we have the duty to uphold honesty and integrity when it comes to design. And it is important that we do not distort our message to the public. Due to the limiting performance of solar cells and storage technology, it is important that we use light materials such as carbon fiber to get the greatest distance out of our energy input. However, when the public asks us if our vehicle can be commercialized in the near future, we convey that it's currently economically unsustainable due to the cost of carbon fiber. We emphasize that the practicality and sustainability of solar vehicles depend on the development of energy storage. And we are honest in conveying that our current vehicle design is not commercially practical due to limitations in technology and access to resources. However, our car is definitely a step forward to what will be a sustainable future.
I'm one of 2 team strategists on the SunSwift team, and my job is to get us to Adelaide in the fastest time possible, which is an interesting problem not only technically but ethically as well. I have to constantly balance the technical merits of a decision to go a certain speed versus the ethical dilemmas it may raise. So one immediate issue that a lot of the time, the speed we want to go to make optimal use of our battery and solar power can be very different from the speed limit of the area. In city areas, we're often limited by the speed limit of the road. Now that means we're going to be traveling at the speed limit itself, which, for a student designed and built solar car with limited means of testing, this obviously poses a safety dilemma, not just for the driver of our car, but also for pedestrians and other traffic. The inverse of that problem also presents itself when we're on the Stuart Highway. So the posted speed limit is up to 130 kilometers an hour in the Northern Territory, while optimally, we only want to be traveling 60 to 70 kilometers an hour. That puts our driver in danger from vehicles which are much larger and traveling much faster than we are. The final issue which we have to consider regularly from a strategy basis is whether we want to overtake other solar cars on the Stuart Highway. Now, this is dangerous because the Stuart Highway is only a single lane for a given direction. So for an overtake maneuver, that means we have to cross over into the oncoming traffic lane. And obviously we're going at a relatively slow speed compared to other traffic. And vision is often limited because other solar cars are always members of a fleet of vehicles. It's my job to decide when it's safe and beneficial to overtake. Now this may involve sitting behind a team going slower than we want for large periods of time, up to half an hour, until we find a safe opportunity which delays us to the finish line.
What has SunSwift done to ensure the safety of our driver and other drivers on the road? As engineers, we need to take precaution in our actions and do what is required to minimize hazards. As part of the risk assessments of driving a solar car on the road, a lead and control vehicle are required at all times in front and behind the solar vehicle. These cars are fitted with amber lights and solar car warnings to ensure that sufficient notice is given to drivers around us. Knowing that other vehicles on the road will be driving at speeds higher than us, we enforced large distances between our fleet to allow others to merge safely. As engineers, we must ensure that users of our products are also safe from harm. Drivers are required to practice and pass a safe exit test in case of a system failure. This involves being able to safely exit the vehicle unassisted within 15 seconds.